This topic is called solving equations with 0, 1, or infinitely many solutions. So I will show you when we have 0 solutions and when we have infinitely many. When we have one solution, that just means that you solved for the variable and you just got one number, and that will be its solution. If you have 0, let's say you're solving for the variable and you end up with something that is never true. Like, let's say you're solving for the variable and you end up with 5 equals 3. That's never going to be true. So what that means is there's no number for the variable that will make that equation true. So that will be 0 or no solution. Infinitely many solutions is if, as you go along and you're solving your equation for the variable, and you end up with something that is always true. Like, let's say you end up with 6 equals 6. In that case, then there's infinite number of solutions, and any number that you plug in for the variable will be a solution to the equation. So they give you 2 problems to do on each problem set. So we'll just start here with this one, and I'll show you what I mean as we solve for each equation. P.S. Please subscribe to my channel and like any videos that you find helpful. So we're just going to look at this first problem that has a -3 and then parentheses v plus 2 equals 2 parentheses v plus 6 plus 7. So we're going to go along and we're going to start with the distributive property. That's what you do in equations if you have a if you have parentheses, sorry, in your equation. So we're going to do -3 times v, -3v. -3 times 2 is a -6. Then we'll do 2 times v, which is 2v. 2 times 6 is a +12 plus 7. Then we're going to combine like terms. The only like terms are this +12 plus 7 on the right side of the equal sign. So the left side stays the same, and we have 2v, and 12 plus 7 is 19. Now, this is the way I like to arrange and look at the term with a variable on it. I look for the side that has the variable with the greatest coefficient. That's the number in front of the variable. The 2 is bigger than -3. So I need to get that -3v off of the left side by adding the entire term. So in order to move terms with variables, you have to add or subtract the entire term. So I'm going to add 3v to this side. So what I have left, oh, and a lot of times people like to put railroad tracks down. If that helps you, do it, because that's like a really good thing to do. -3v plus 3v is 0, so we're left with -6. 2v plus 3v is 5v plus 19. Now we have a regular equation. We have to get rid of what's added and subtracted to the variable term first. So we're adding 19. We want to subtract 19, get rid of that. -19 minus 6. They're both the same sign. So we keep them negative and we add 19 to 6 to get 25. So -25 equals 5v. And then we divide by 5 because we want to get 1v. So v is equal to -5. This is the case where they say there's one solution. So we click this one that says v equals, and we go ahead and put -5 in there. And then we're going to do the second part of this problem. So I'm going to erase my work here. And then we'll start on the second question. So we have -2, and then the parentheses y plus 1 plus 5y equals 3, parentheses y plus 1 minus 2. So we're going to do our distributive property first on both sides here. So we have -2 times y is -2y. -2 times 1 is a -2. Plus 5y equals 3 times y is 3y, and 3 times 1 is 3 minus 2. Then we combine like terms. Looks like we need to do this combining on both sides. -2y plus 5y is a +3y. On this side, 3 minus 2, those two are like terms, becomes a +1. There's no way that 3y minus 2 is going to equal 3y plus 1, but let's continue, let's pretend we're going to get all of our y's on the same side. Because they're the same, if you subtract off 3y, you're going to get -2 equals +1. That can never be true. So never true means no solutions. So we're going to click no solution for that second part of our first problem. And then we're going to do another practice. I don't know if I'll do 3 practice today. Hopefully we'll get one that has infinitely many solutions so you can see what it looks like to get that. I'm going to go ahead and do the distributive property instead of writing the whole problem first. So -3 times u is -3u. -3 times 5 is -15. We have that plus 5u. 2 times u is 2u. And 2 times 6 is 12. So why did I put a y on the 5? I don't know. That's supposed to be a u. So we'll just kind of change that to a u. There we go. -3u plus 5u becomes a positive 2u. Minus 15 equals 2u minus 12. There's no way these are going to be equal. Again, if you subtract 2u, you get -15 equals -12. Never true. So that's no solution. Okay, let's do the second part. So we'll distribute. We have 6y minus 12 plus 2. 2 times 3 is 6y minus 10. Ooh, this is looking good. So when we combine -12 and plus 2, we get a -10. So we have 6y minus 10 equals 6y minus 10. That's going to always be true. They're the same. So, but let's just keep continuing. We subtract off the 6y just in case this is how you want to see it. So this is -10 equals -10. This is always true. So always true means any number that you put in for y will work. So it means there are an infinite number of solutions. So, oops, I usually abbreviate that. So we're going to go with all real numbers are solutions. And I'm going to go ahead and end the lesson there.